Okay, hello everyone. Okay, let us continue the second part of today's class. Okay. Okay, finally is the 802.11ac. Okay, what is this? Okay, problem 6. What is 802.11ac? Solution: IEEE 802.11ac 2013 or 802.11ac is a wireless networking standard in the IEEE 802.11 set of protocols, which is part of the Wi-Fi networking family, providing high-throughput wireless local area networks (WLANs) on the 5 GHz band. Okay. So 802.11ac is an enhancement of the IEEE 802.11n standard, and the antenna configuration is 8 by 8. Okay, so table 1.4 lists some commercial wireless standards that use MIMO technology. Okay, in general, the standards listed in this table support the following types of multi-antenna techniques. First, Alamuti space-time coding for transmit diversity. Second, eigenbeamforming spatial multiplexing. Third, blast spatial multiplexing architectures. Fourth, conventional beam and null forming. Okay, what is null forming? Please see the handout. Okay, page 185. Problem 1. What is null forming? Solution: in the receive beamformer, the signal from each antenna may be amplified by a different weight. Different weighting patterns, for example, Dov-Chebyshev, can be used to achieve the desired sensitivity patterns. Okay. A main lobe, please see figure 8. Okay, figure 8. Okay, figure 8 is a typical directional antenna radiation pattern in polar coordinate system representation, showing the main lobe, side lobes, and back lobe. The radial distance from the center represents signal strength. Okay, here is the main lobe, okay, the red one. And here are side lobes, the gray ones. And here is the back lobe, the purple one. Okay, and here is the 0 degree, 90 degree, 180 degree, and 270 degree. Okay, antenna faces to 0 degree. Okay, here. Okay, a main lobe, please see figure 8, is produced together with nulls and side lobes, as well as controlling the main lobe width, beam width, and the side lobe levels. The position of a null can be controlled. Okay, this is so-called the null forming. This is useful to ignore noise or jammers in one particular direction. Okay, what are jammers? There are interferers. while listening for events in other directions. A similar result can be obtained on transmission. Okay. So finally is the conventional receive diversity. Although the details of how each of these standards implements MIMO vary, the underlying principles are the same. In this course, we focus on the fundamental concepts of MIMO, which will give the reader, that is, give you, the necessary background to read and understand the details of the standards. Chapter 11 describes how MIMO is implemented in the IEEE 802.11n and LTE standards for the purpose of demonstrating how the concepts described in this course are implemented in practice. Okay, next let us go to section 1.8.2, Measured MIMO Performance. This section describes performance measurements that empirically. Okay, what is empirically? Let us see the handout. Okay, page 189, problem 1. What is empirically? Solution: empirically is an adverb. Definition of empirically: in an empirical manner, with a basis in or reliance on information obtained through observation, experiment, or experience. A theory that has not yet been tested empirically. Okay. Okay, empirically demonstrate the advantages that MIMO can provide. A particularly clear and compelling. Okay, what is compelling? Okay, let us see the handout. Okay, problem 2. What is compelling? Solution: compelling is an adjective. Definition of compelling: that compels, such as A. Forceful, a compelling personality, a compelling desire. B. Demanding attention, for compelling reasons. The novel was so compelling that I couldn't put it down. C. Convincing, no compelling evidence. Okay, go back to the slides. And compelling paper that demonstrates the performance benefits of MIMO was presented at the Military Communications Conference, MILCOM, in 2010 by Lai et al. Okay, please see reference 53. Okay, reference 53 is written by Lai et al. Okay, measurements of multiple input, multiple output MIMO performance under Army operational conditions in Military Communications Conference 2010, MILCOM 2010. Okay. Okay, in that paper, they present results from demonstration tests that were performed to quantify the benefits of a MIMO communication system called Mobile Networked MIMO MNM that was developed by the Defense Advanced Research Projects Agency, DARPA, for military applications. Okay, what is DARPA? Let us see the handout. Okay, page 190, problem 1. What is Defense Advanced Research Projects Agency, DARPA? Solution: the Defense Advanced Research Projects Agency, DARPA, is a research and development agency of the United States Department of Defense responsible for the development of emerging technologies for use by the military. Okay, for example, if you go to a company to work, find a job, okay, you may find a job in the R&D department. That is the Research and Development Department, 研发部门。Okay. DARPA for military applications. The MNM MIMO radio tests were conducted in various environments, including indoor, outdoor, open space, and in dense foliage. Okay, what is foliage? Please see the handout. Page 191, problem 1. What is foliage? Solution: foliage is a noun. Definition of foliage: 1. A representation of leaves, flowers, and branches for architectural ornamentation. For example, the door frame was decorated with beautifully carved foliage. 2. The aggregate of leaves of one or more plants. Okay, for example, trees with colorful autumn foliage. 3. A cluster of leaves, flowers, and branches. A wreath of foliage adorned her front door. Okay, so simply speaking, the foliage means leaf, 叶子的意思。Okay, the MNM radio used in these tests consists of up to 4 transmit antennas and 4 receive antennas, and table 1.5 lists the parameters of the MNM radio used in this demonstration. Okay, let us see table 1.5. Okay, in table 1.5, there are MNM MIMO radio system parameter values. Okay, first, the RF carrier is 1.4 to 1.4835 GHz and 4.9 to 5.8 GHz. And the output power total is 250 milliwatts, 2 watt with external PA. What is PA? Okay, please see the handout. Okay, page 192, problem 1. What is PA? Solution: power amplifier, 功率放大器。Okay. Next, bandwidth is equal to 0.625, 1.25, 2.5, 5, 10, 20 megahertz. And the data rates are 1.5 megabits per second to 260 megabits per second. And the modulation is the coded OFDM with 64 128 FFT sizes. Okay, what are OFDM and FFT? Okay, please see the handout. Problem 2. What is OFDM? Solution. In telecommunications, orthogonal frequency division multiplexing (OFDM) is a type of digital transmission and a method of encoding digital data on multiple carrier frequencies. Problem 3. What is FFT? Solution. A fast Fourier transform FFT is an algorithm that computes the discrete Fourier transform DFT of a sequence or its inverse IDFT. Okay, here IDFT means inverse discrete Fourier transform. Okay, if you want to know more about the OFDM and FFT, you can take the course OFDM-A offered by Professor Zhongxian Liu. Okay, next, the antenna configuration is M by N, where 1 is less than or equal to M and N and N are smaller than or equal to 4. And the MIMO processing includes spatial multiplexing, space-time coding, eigenbeamforming, and receive diversity. Finally, the number of data streams are 1, 2, 3, and 4. Two performance metrics were used in this test to quantify the performance improvement due to MIMO. One of these metrics, called throughput gain (TPG), is defined as the ratio of MIMO throughput over SISO throughput given the same total transmit power, spectrum usage, and channel conditions. So the TPG is defined as TP MIMO over TP SISO, where TP MIMO and TP SISO denote the MIMO and SISO throughputs respectively. The throughput in turn was computed based on the collected packet error rate, PER. Okay, what is packet error rate? Please see the handout. Page 195. Problem 1. What is packet error rate, PER? Solution. The packet error rate, PER, is the number of incorrectly received data packets divided by the total number of received packets. Okay. Okay, packet error rate PER and the data rate are as follows. TP throughput is equal to 1 minus packet error rate PER times R. Okay, so please note that throughput is not equal to data rate. Okay, it is equal to 1 minus packet error rate times the data rate, because the throughput only takes the successful packet transmission into account. The second performance metric used in this study was the transmit power savings, TPS, defined as the ratio of transmit power used in SISO divided by the required power for MIMO, when operating at the same throughput. This matrix was used to quantify the transmit power savings of MIMO over SISO. Table 1.6 summarizes the results from this study, separated according to whether the radios were operating within line of sight LOS of each other or were non-LOS, NLOS. Okay, what are line of sight and non-line of sight? Please see the handout. Page 197, problem 1. What is line of sight? Okay. Solution. Line of sight LOS propagation is a characteristic of electromagnetic radiation or acoustic wave propagation, which means waves travel in a direct path from the source to the receiver. Please see figure 9. Okay, figure 9 shows the line of sight propagation to an antenna. Okay, here is an antenna. However, it should be ANTENNA, okay, not E. Okay, on the top of the antenna, it can transmit signals to the horizon. Okay, if there is no any obstructions behind them. Okay, so this path is called the line of sight. Okay, then problem 2. What is non-LOS, NLOS? Solution. Non-line of sight NLOS and near line of sight are radio transmissions across a path that is partially obstructed. Okay. Let us go back to the slides. Okay, let us see table 1.6. Table 1.6 is the summary of measured MIMO performance improvement from MNM radio field demonstrations. Okay, in the left column it is for line of sight transmission, and TPG is the throughput gain, and TPS is the transmit power savings. And in the right column, it is for the non-line of sight transmission, and TPG and TPS again. The results from this study are interesting for two reasons. One, they show, as expected, that MIMO is capable of significantly increasing throughput. Okay, you can see that the throughput gain is the mean value is equal to 1.9, is greater than 1. And for the non-line of sight transmission, the throughput gain is 3.3, is also greater than 1. Okay, so MIMO has the higher throughput than that of SISO. 2, they show that MIMO increases throughput by more when operating in a non-line of sight environment than it does in a line of sight geometry. Okay, you can see that for the non-line of sight transmission, the throughput gain is equal to 3.3, which is larger than that of the line of sight transmission, and which is equal to 1.9. This can be explained by the fact that line of sight conditions have less multipath scattering than non-line of sight geometries. Okay, since spatial multiplexing uses multipath scattering to increase throughput, the lower, okay, it is 25 minutes. Let us take a break.